Alright, this example is nice. It's not as abstract as example 4, or example 5. Let A be the area underneath the graph of this over this interval. Compute A as a limit as R sub n at n approaches infinity. So it's kind of cool. They give this to you when you should probably be expected to know how to do this top part without being told to compute A as the limit approaches infinity of R sub n. Now R sub n, you guys know, is a Riemann sum. Now I can't really draw all the rectangles here because it's approaching infinity, but this is just a visual. We have an infinite number of rectangles that we're calculating the area for. We know from earlier discussions that the more rectangles that you have, the more accurate your area is. And actually, if you have an infinite number of rectangles, that is accurate. So, what do we do? So first we got to have what R sub n equals. I'm going to write it in summation notation, which is delta x times the sum of, j equals 1, that's our dummy variable, and we're going to keep n. N is supposed to represent the number of rectangles that we have underneath, that we're finding the area of, but since it's going to be infinity, we'll leave it as n. And then we're going to use this function to calculate the heights of each of our rectangles. That's what this is essentially. We're going base times height to find the area of each rectangle, but we factor out the base since the base is the same for each rectangle, and then we're going to use this to find all of our heights. So since this is a right endpoint rectangle or Riemann sum, we're using this one. We're using the 3. Well, would it be 3? But to represent it, we would say a plus the change in x. But we would also want to put j so that we can represent all the heights of the rectangles. So now we just need to plug in all the numbers that we can know. We can know delta x. Delta x is found by taking the length of the interval. Now the length of our interval is 2, so 2 to 4 is 2, and then we divide it by the number of rectangles, which we don't know. We're just going to keep it as n. So let's plug these in. We have 2 divided by n, which is our delta x, sigma, j equals 1 going to n, and then we have, we know what a is. A is 0. Actually, I'm going to write that over here. No, it's not 0, it's 2. That's the beginning of our interval. This is 2 divided by n, and we have a j multiplying to that. So we're going to plug this into f, and f is right here. So we have to write all that stuff out. Ooh, that looks nasty. So we have 2 times, we're going to put 2 in right there. Actually, let's write that afterwards. 2 plus, that would be 2j divided by n. We're going to square that. And minus 2 plus 2j divided by n, and plus 3. So all of this is inside of our sigma. Now this is where our algebra skills are going to really come in handy here. We're going to have to simplify all this stuff in order to get to the point where we can use the power sum and simplify this even more. And once we can use the power sum and then we simplify more, then we could take the limit as n approaches infinity. Alright, so think of this as in 3 parts. The first part we just did, and we got to this part where we have the function and we have everything plugged into our R sub n summation formula. We have our delta x, we have the a plus delta xj plugged into the function. Now right here I'm going to start simplifying. Alright, this is the second part, doing all the algebra to simplify the function. So this would be 2 times, that would be 4 plus 4jn 4j divided by n plus 4j divided by n, which simplifies to 8j divided by n. I'm going to go ahead and simplify that right now. 8j divided by n plus 4j squared divided by n squared. And then we have to multiply everything by 2. This is going to be negative 2 plus, minus 2j divided by n. Then we have plus 3. And then I distribute that 2 to get 8 plus 16j divided by n plus 8j squared divided by n squared minus 2j divided by n plus 3. We could add our constants together. That 2 is going to make that 3 into a 1, so we have a 9. We're going to put him at the end. And then this guy is the same as the him, but he's negative 2. So we have negative 2, that's going to be 14j divided by n. Actually, let's move him over right next to the 9. And then, so that's that guy and that guy. We did that guy. Okay, so now we just have 8j squared divided by n squared. So I'm going to take this and put it in place of that. So let's go ahead and erase some stuff so I have some space. Okay, so that was the big part 2. So we have 2 over n, j equals 1 to the n. Now we have 8j squared divided by n plus, actually, you know what, I'm going to start splitting this up now. So I'm plugging this in, and I want to do the sigma for each of these. So let's put a big bracket around this, and we're going to have another sigma for the next one, which is 14j divided by n plus another sigma, j equals 1, 9. Alright,